All right, so on the previous slide, we saw a little summary of the rational zeros theorem. Here we actually want to use the rational zeros theorem. Okay, so we have this request here. It says, for the polynomial function, list all possible rational zeros. Well, according to the rational root theorem or the rational zero theorem, if I have a zero of the form p over q, where p and q are integers, and p over q is in reduced form, that's a rational number, then p must be a factor of the constant term. So in other words, p must be a factor of -8. So then we list all the numbers up here that divide -8. So that would be positive or -1, positive or -2, positive or -4, and then positive or -8. Those are all the numbers that divide the number -8 evenly. Okay, so if I have a rational number that is a zero and it's in reduced form, the numerator has to be a factor of a -8. The denominator, that's this q, has to be a factor of 15. So then we list all the numbers that divide the number 15. Well, again, 1 divides 15, so does -1. 3 and -3 also divide 15. Likewise, 5 and -5. And finally, 15 and -15. So we haven't listed any zeros, but what we have done is listed all the possible values for the numerator and all the possible values for the denominator. Our last step is to just mix and match all the possible combinations so that we have then all the zeros, right? And for this one, I think we're actually going to have a lot of them, okay? So we're going to place all the ones at the top with all the ones at the bottom. So 1 over 1 gives me 1. 1 over 2, or 1 over 3, that's a third. Okay. 1 over 5, 1 over 15. Okay, so I've paired 1 with all the ones at the bottom. Now I need to do the same thing with 2. So 2 over 1 is 2. 2 over 3, that's 2/3. Okay, 2/5. 2/15. Okay, then I'm done with the 2, right? I've paired 2 with all of them. So now 4. So that's 4 over 1, which is 4, 4/3, 4/5, and 4/15. And finally, we're going to pair this 8 with all of these. So 8 over 1, right? 8 over 3, 8/5, and 8/15. Oops, 8/15. Here, let me just rewrite that. So plus or minus 8 over 15. All right. Okay. So there we have it. 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 potential rational zeros. Now, the rational root theorem does not say that any of these are really guaranteed to be rational zeros, but what it does say is that if I do have a rational zero, then it has to be one of these. So then if someone were to ask you to find the rational zeros, you'd start off here by testing any of these rational zeros to see whether or not they are indeed zeros. All right? So then I will see you in the next video.